Hi and hello to everyone. In this video, we are going to discuss about the nodal analysis. It's also called as node voltage method. Okay, so before undergoing into this, you have to understand a few points. That's current always flows from higher potential to lower potential. Okay. Particularly in a resistor. Okay, so what is the potential? Potential is nothing but the voltage. It's a higher voltage to the lower voltage. So if I say a current I is nothing but the voltage, that is voltage higher minus voltage lower divided by the resistance. Okay, with this in mind, to apply nodal analysis, we will be applying Kirchhoff's current law. Kirchhoff's current law, which is KCL. What does Kirchhoff current law states? Current, you can say sum of current entering a node is equal to sum of currents leaving a node. Okay, this is the Kirchhoff's current law, right? So with this in mind, we will straight away move into an example. Okay, the question is find the nodal voltages. Okay, find nodal voltages. Okay, this circuit has two current sources. One is 5 ampere, another is 10 ampere, and three resistances. 3 resistors, 2 ohms, 4 ohms, and 6 ohms. Okay, they are asking find the nodal voltages. First, you have to identify what is a node. Node is the one where two or more elements are connected. So this is node 1, this is one node, this is another node. So this entire thing is another node. Okay, and this is the third node. And this node is called reference node. Reference node, or also called as ground node, whose voltage is 0 volt. And let me assume the voltage at the node 1 is V1, node 2 is V2. Okay, and we have to apply the Kirchhoff's current law for each of the node. In this, let me assume the current flowing through 2 ohms is I1, current flowing through 4 ohms is I2, current flowing through 6 ohms is I3. Okay, so we apply Kirchhoff's current law at node 1. Okay, at node 1, what is node 1? This entire thing is node 1. Okay, this entire this is the node 1. Okay, in node 1, what is the current entering the node? 5 ampere is entering the node. What is the current leaving the node? I1 and I2. So sum of the current is I1 plus I2. Okay, so it is 5 ampere is equal to, what is I1? It's a current flowing through 2 ohms. Okay, let me draw it separately here. This is 2 ohms. The potential at this point is V1. The potential at this point is 0 volt ground reference node. So what is the current is flowing from top to bottom, which is I1. So the potential difference is V1 minus 0, okay, divided by 2 ohms. So I1 is V1 minus 0 divided by 2. What about I2? So this is I2. This is the current flowing through 4 ohms. This current is I2. This side the potential is V1. The other side the potential is V2. What is the potential difference? Yes, the potential difference is V1 minus V2 divided by resistance 4 gives I2. So V1 minus V2 divided by 4. So I'm taking LCM, 2V1 plus V1 minus V2. Okay, so it is 23V1 minus V2. This is equation 1. Similarly, we will apply Kirchhoff current law at node 2. Okay, what are the currents entering the node? We can clearly see the current entering the node is 10 ampere is entering. This is because it's a current source. I2 is also entering. Okay, so it is 10 plus I2. What is the current leaving the node? We can clearly see your 5 ampere, which is a current source, which is leaving the node, and I3 is also leaving the node. So 5 plus I3. Okay, so already we have found out what is I2. So 10 plus I2 is V1 minus V2 divided by 4, 5. What is I3? Yes, I will. So this is I3, 6 ohms. This is I3. Here the potential is V2. Here the potential is 0. Okay, so the current is flowing from top to bottom. So higher potential is I3 is equal to V2 minus 0 divided by 6. Okay, so V2 minus 0 divided by 6. Right, so bring the 5 to the left side. It becomes minus V1 minus V2 by 4 plus V2 by 6. Take the LCM, become 24. This is 5. So it becomes minus 6V1 plus 6V2 plus 4V2. So 5 24s are 120 is equal to minus 6V1 plus 10V2. This is the equation 2. Okay, on solving these two equations, solving 1 and 2, you should be getting V1 as 13.33 volt, V2 as 20 volt. Okay, that's it. I'll move to another problem. Second problem. Okay, find nodal voltages. Find nodal voltages. Okay, so what are the nodes we have? We have a node. This is node 1. This is node 2. This entire thing is node 3. Okay, so for node 1 the voltage is V1, node 2 the voltage is V2. For the node 3, it's a reference node, the voltage is 0 volt. Let us assume the arbitrary current direction as any direction you can assume, top to bottom. Here for I am just changing, top to bottom is I1, this side it is I am assuming as I2. 7 ohms current flowing through 7 ohms I am assuming as I3. Okay, so apply Kirchhoff current law at node 1, right? So it is, what is the current entering the node 1? So this entire thing is a node 1, right? This is node 1, this is node 2. Node 1, 3 ampere is entering, I1 is entering, I2 is entering. What is the current leaving? Nothing, no current is leaving, so it is 0. Okay, so 3, regarding I1, this is 2 ohms, I1 is this, and the voltage at this point is reference 0, here it is V1. Okay, so what is the potential difference? Potential difference is the current is flowing from bottom to top, right? So the bottom side the voltage is 0, so I can say the potential difference is 0 minus V1 divided by 2. The resistance gives I1, so it is 0 minus V1 divided by 2. What about I2, which is the current flowing through 6 ohms? Okay, the current is flowing from right to left, so the potential difference is V2 minus V1 divided by the resistance 6 gives the current I2. So V2 minus V1 divided by 6 equal to 0. Okay, take the LCM. 6 is 6 minus 3V1 plus V2 minus V1 equal to 0. Okay, so it is minus 4V1 plus V2 equal to minus 6. This is equation 1, right? Now we will apply KCL at node 2. In node 2, what are the currents entering? No current is entering. Okay, if you take the node 2, no current is entering, so it is 0. What are the currents leaving? I2 is leaving, I3 is leaving, 12 ampere is leaving. Okay, so what is I2? We have found out I2 as V2 minus V1 divided by 6. What about I3? For regarding I3, I can write here. So it is 7 ohms. This is my I3. Here it is V2. Here it is 0. So it is V2 minus 0 by 7. Okay. Plus, got it? So bring 12 to the left side, it becomes a minus 12. So take the LCM, which is 42. So 7V2 minus 7V1 plus 6V2. Okay, so it is minus 7V1 plus 13V2 divided by 42, so to minus 12. So it is minus 12 times 42 is equal to minus 7V1 plus 13V2. This is the equation 2. Just to solve this equation 1 and 2, you will be getting the V1 as minus 6 volt, V2 as minus 42. sorry, here we made a mistake. It should be like 6 times, taking LCM, this would be 18. Okay, should be minus 18 on solving. Yes, okay, please make a note. 18, right? On solving this, you should be getting the answer as V1 and V2 as V1 is minus 6, V2 is minus 42. Okay, thanks for listening.